Hi, welcome to Robotics Lab, experiment number 4, and today we will use potentiometer as sensor with serial communication for servo motor control. For the objectives of the experiment, number 1, to convert analog signal to digital value for the Arduino to process. Number 2, to control the angular displacement of the servo motor using the potentiometer. And number 3, to display data in serial monitor and LCD display coming from the Arduino. For the equipment and materials, we only need one personal computer, one Arduino microcontroller, one 16 by 2 LCD display, two potentiometer, one USB cable, one power supply, and one breadboard. So for the introduction, in this activity, we will be going to control a servo motor using a potentiometer as a sensor. We will configure the potentiometer into a voltage divider circuit and feed the middle pin to the Arduino to have a variable value as we rotate the knob of the potentiometer. We will make use of the analog to digital conversion of the Arduino microcontroller to process the data. Using analog read, the potentiometer value will be read as between values from 0 to 1023, and using mapping, the potentiometer will be processed between values from 0 to 180 for the servo motor control. Now let's create the circuit in Fritzing. Here in Fritzing, this is our circuit design. First, the 5V power supply and the power pin is connected here, and the ground pin is connected here. Then to integrate an LCD display to the Arduino, first we connected the VSS to the ground, then the VDD second pin to 5 volts. Then to control the contrast or brightness of the LCD, we connected the third pin or V of the LCD to the middle pin of this potentiometer. Then the first pin of this potentiometer, we connected it to ground, and the third pin of this potentiometer is connected to 5 volts, so that when I turn the knob of this potentiometer to the left, the resistance increases, and the brightness of the LCD decreases or contrast increases. Then when I turn the knob of this potentiometer to the right, the resistance decreases and the LCD brightness increases or the contrast decreases. Then going back to the LCD display, fourth pin of the LCD or RS register, it is connected to the 12th digital pin. Then 5th pin or RW read and write, it is connected to the ground. Then 6th pin E enable, it is connected to the 11th digital pin. Then 15th pin A or anode, it is connected to 5 volts. Then 16th pin of the LCD K or cathode, it is connected to the ground. Then 14th pin D7, it is connected to 2nd digital pin. 13th pin of the LCD D6 connected to 3rd digital pin. Then 12th pin D5 connected to 4th digital pin. Then 11th pin of the LCD D4 connected to the 5th digital pin. Then for the second potentiometer that will be used as sensor, the middle pin or the second pin of the potentiometer is connected as analog input. Then the first pin of this potentiometer is connected to 5 volts, and the third pin of this potentiometer is connected to ground. So that when I turn the knob of this potentiometer to the right, the value or resistance increases, and the value that will be read by the Arduino is 1023. And when I turn the knob of this potentiometer to the left, the resistance decreases and the value read by the Arduino will be 0. Then for the servo motor, the PWM output, yellow, was connected on the 9th digital pin of the Arduino. Then the red wire of the servo was connected to 5 volts, and the black wire of the servo was connected to the ground. Then for the LCD and servo, we also connected the ground here located in the digital pins. Here in the schematic, we can see the detailed version of our breadboard circuit design. Then we can see in the LCD, the VSS and the RW pin was connected to the ground, and VDD connected to positive 5V power supply. Then VO connected to second pin of the first potentiometer. Then RS pin, fourth pin connected to D12. Fifth pin enable connected to D11. Then data bus 4 or 11 pin connected to D5. DB5 connected to D4. DB6 connected to D3, DB7 connected to D2, then for the anode, LED plus connected to 5V power supply, LED minus or cathode connected to the ground. Then for the second potentiometer as sensor, the middle pin or second pin was connected as analog input in A0 of the Arduino. Then first pin connected to 5 volts and third pin connected to ground. Then for the servo motor, then the D9 PWM of the Arduino was connected to the pulse pin of the servo. Then the positive of the servo was connected to 5 volts and the negative pin of the servo was connected to the ground. Now let's create the code. Here's the Arduino code for experiment number 4, potentiometer as sensor with LCD display. Here are the following parameters or connections that we made a while ago. So first, here in the code, we included the servo library and the LCD display library. Then for the LCD display pin assignment, we use 12, 11, 5, 4, 3, 2, digital pins of the Arduino. Then servo space my servo, we name our servo motor as my servo. Then we declared pot pin with initial value of 0 as integer. And we also declared angle as integer. And for the void setup, pin assignment, pin mode in close parenthesis A0, input. Then the middle pin of the potentiometer will be as input in analog pin 0 or AO. Then my servo that attach in close parenthesis 9. So we attach the PWM pin of the servo motor to pin 9 of the Arduino. And for the serial monitor setup, serial that begin 9600, the baud rate of the serial monitor. Then for the LCD display setup, LCD that begins 16,2, so that enables the 16 columns and the 2 rows of the LCD display. Then for void loop, pot pin equals analog read and close parenthesis AO, so that will read the input on the analog pin 0 coming from the potentiometer. Then angle equals map and close parenthesis pot pin, 0, 1023, 0, 179. So whatever value from the pot pin will be scaled from 0 to 1023. And for the servo motor control, the value from 0 to 1023 will also be scaled from 0 to 179. Then my servo that write in close parenthesis angle, so whatever value of the angle is, the microcontroller sends a signal to the servo motor to execute the angle value for the position of the servo. Then to display the potentiometer value and servo angle in the serial monitor, serial.print pot value, then serial.print ln pot pin. So whatever value from the pot pin will be displayed here. Then we use print ln for space. Then serial.print servo angle, serial.print ln, and close parenthesis angle. So whatever value of the angle will be displayed here in the serial monitor, and print ln for space. Then to also display the potentiometer value and servo angle in the LCD, first LCD that set cursor in close parenthesis 0, 0. So we are setting this text in the first column and first row of the LCD. Then LCD that set cursor 12, 0. So we are setting this text, the pot pin value, to be displayed in the 12th column and first row of the LCD. Then for the servo angle, we will be using the second row of the LCD. So LCD that set cursor in close parenthesis 0, 1. So we are setting this text to be put in the first column and second row of the LCD. Then LCD that set cursor in close parenthesis 13, 1. So we are setting the angle value to be displayed in the 13th column and second row of the LCD. Then we also place delay 50 for stability of values to be displayed in the LCD. And we also place LCD.clear. Now let's test the circuit, compile and upload. Then let's go to Tools, Serial Monitor, so that we can compare the potentiometer and servo angle value here in the serial monitor and in the LCD display. So first, potentiometer and servo angle is 0. Then let's move the potentiometer. $115, $20. In the LCD display, it is reading 114 and 19 or 20. Then also in the serial monitor, 114 for the potentiometer value and servo angle is 19. Then let's try to increase more. 239, 231 for the potentiometer value, servo angle 40. Then in serial monitor, the same potentiometer value 231 and servo angle 40. Then let's try. We can also see the servo motor moving. Let's try to 180, 1023 to 179 here in the LCD, and in the serial monitor 1023 to 179. Now let's try to decrease. 927, potentiometer value, servo angle 162, LCD and serial monitor 927, servo angle 162. Now let's try to decrease. 127, servo angle, potentiometer value 729, LCD. Then serial monitor also 729 potentiometer value. Here we can say that we configured the LCD display and the serial monitor to display the same values coming from the potentiometer sensor and the angle of the servo motor. There. Decrease. 0. 100. See? See, the serial monitor and the LCD displays the same value. Sometimes we can see that the servo motor is not stable. To make it stable, just increase the delay value. We can also see the function of the first potentiometer. So we can decrease the brightness. Turn it off the potentiometer to the left. There. Display is not visible. Then let's turn to the right. Now let's turn to the right. There. Then let's adjust the second potentiometer. 0 degrees. And increase up to 1023 of the potentiometer. 179. The maximum set angle for the servo motor.